Hey, grade 12s. Today we're going to talk about permutations of distinguishable objects. That basically just means different objects. So let's go ahead and see what this is all about. How many different words, and we say that with quotations, so we're not really talking about words, we're talking about arrangements of letters, can be formed using the letters from the word brochet. Brochet has 7 letters, so it's important to note that there are 7 ways to choose the very first letter. Once you choose that letter, though, it's chosen, and you can't choose it again. So then there are 6 ways to choose the second letter. Okay? And once that second letter is chosen, then there's 5 ways to choose the third letter. Okay? 4 ways to choose the fourth letter, 3 ways to choose the fifth letter, 2 ways to choose the sixth letter, and 1 way to choose the final letter, because that's all that's left. Okay? Good enough. So if we multiply 7 times 6 times 5 times 4 times 3 times 2 times 1, we get a total of 5,040 words. Okay? Now, in math, we often try to write things in a more simplified way to make things easier. We use multiplication as a short form for repeated addition, exponents for repeated multiplication, and there's also a notation that's going to help when we have something like this. 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So what that notation is it's actually called factorial notation. And factorial notation is when you have something like n factorial. And how we denote that is an n with an exclamation point. And n factorial is n times n minus 1 times n minus 2 times n minus 3 times dot 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 times 3 times 2 times 1. So like if we take a look at up here, 7 times 6 times 5 times 4 times 3 times 2 times 1 is the same as 7 factorial. Okay? 7 factorial. All right. So we're going to use that idea to help us do questions from today's work. Calculate each factorial. Okay, calculate each factorial. 3 factorial. So 3 factorial is fairly straightforward. It just means 3 times 2 times 1, which is 6. Pretty straightforward. 6 factorial. 6 times 5 times 4 times 3 times 2 times 1. So for example, we just did 3 factorial. And 3 factorial equals 6. So now what we should try and do is say, okay, well now we're going to take that 6 times 4, 24. Multiply that by 5, 120. Multiply that by 6, and you get 720. So that is the value of 6 factorial. Now 13 factorial is something that you are probably going to need to use a calculator in order to figure out. So your calculator has an X factorial button. If you're using one of my classroom calculators, it's Shift 3. You're not going to want to do this one by hand, because even though 13 is not that far away from 6, 13 factorial is a huge number. It's 6, 227, 020, 800. So it's 6,227,020,800. That's 13 factorial. It's a massive number. All right. But we're going to use some strategies in order to simplify factorial expressions, and that's what we're going to do right here for the next couple questions. What would 9 factorial over 7 factorial look like? And in order to help us, let's think about this way. 9 factorial is equal to 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So interestingly enough, we have a 7 up here and a 7 down here. Chop, chop. 6 and 6, 5 and 5, 4 and 4, 3, 3, 2, 2, 1, 1. That leaves us with just 9 times 8, which is 72. So that's what that would be. 9 factorial over 7 factorial turns into 72. And if we move on to the next one, we have 8 factorial over 5 factorial, 3 factorial. So same kind of idea here. 8 factorial is 8 times 7 times 6. Now we're going to write it as times 5 factorial. Why are we doing that? Well, we're doing that because there's a 5 factorial in the bottom. And if we have a bunch of products on top and a bunch of products on the bottom, we can go chop chop and those 5 factorials go away. And from what we learned earlier, 3 factorial is 6, so 3 factorial can go away as long as you take 6 with it because they both are equal to the same thing. And that leaves us with just 8 times 7. So 8 times 7 is 56. And that's the final answer. So we get that 8 factorial over 5 factorial, 3 factorial, to simplify really nicely. And just remember what we did with the 8 there. The 8 factorial is we wrote it as 8 times 7 times 6 times 5 factorial because there's already a 5 factorial in the denominator and you're able to cancel them and then simplify from there. Okay. Next example. Jimmy wants to listen to his 8 favorite AC/DC songs. How many ways can he do this? So basically, we have to think of it this way. In the first spot, there's 8 choices, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So that's equivalent to 8 factorial. And 8 factorial is going to be 40,320. So there's 40,320 ways that Jimmy can listen to his 8 favorite AC/DC songs in order. There's that many different orders in which you could play the songs. Okay? Now, what if Jimmy only had time to listen to 4 of his favorite 8 songs? How many different playlists of 4 songs could he pick from those 8 songs? We need a way to solve that problem. So now we're going to take a look at a little bit more theory in order to help us do that. A permutation of n distinct items taken r at a time is an arrangement of r of the n items in a definite order. Such permutations are sometimes called r arrangements of n items. The total number of possible arrangements of r items out of a set of n is denoted by NPR or P bracket N comma R. There are N ways of choosing the first item, N minus ways of choosing the second item, and so on until we get to N minus R plus 1 ways of choosing the rth item. Using the fundamental counting principle, NPR is equal to N times N minus 1 times N minus 2 all the way down to N minus R plus 1. But it's often more convenient to write it in terms of this way here. NPR is equal to N factorial over N minus R factorial. So, let's go back to our question. If he only has time to listen to 4 of his favorite 8 songs, how many ways can we do that? So, in order to do this, we're going to figure out what 8p4 is. So we have 8p4. So that's 8 factorial over 8 minus 4 factorial. So it's 8 factorial over 4 factorial. Now remember what we said about the factorials. 8 times 7 times 6 times 5 times 4 factorial over 4 factorial. So we're going to get chop, chop. And then we have 8 times 7 times 6 times 5. So that's going to be 40 times 42, which is going to be 1,680 ways. So that's the number of ways he can listen to 4 of his favorite 8 AC/DC songs. Okay? All right. How many different ways can the president and vice president of student council be chosen from 10 members? We assume that every member has an equal chance of being chosen. And with that said, there's going to be 10 choices for the first position, 9 choices for the second. So it's 10 times 9, which is 90. You could also go 10p2, which is 10 factorial, over 10 minus 2 factorial. So 10 factorial over 8 factorial, which would be 10 times 9 times 8 factorial over 8 factorial. And then that would give us 10 times 9, which is 90. So we get the same answer. It's just 2 different ways, 2 different approaches, but it's still working towards figuring out that there's 90 ways that the president and vice president position can be filled from a group of 10 people. Okay? Now we're going to talk about circular permutations. And when we talk about circular permutations, what we're kind of asking is, how many ways can N people sit around a circular table? So maybe 5 people around a table, maybe 10 people around a table. Here's the interesting thing to note. One person must be used as a placeholder, and there's N minus 1 factorial ways of doing it. So how many ways can 5 friends sit together at a circular table? If you would like, you could draw this out. Placeholder, then there's still 4, 3, 2, 1, 4 factorial ways. So there's 24 ways of seating your friend at a circular table. Okay? Solve for n factorial over n minus 2 factorial equals 56. So simplifying here, n factorial is n times n minus 1 times n minus 2 factorial all over n minus 2 factorial. And what we're going to get is those n minus 2 factorials are going to cross out. If we multiply n times n minus 1, it's n squared minus n. Bring the 56 over, you get minus 56. So it's n minus 8, n plus 7 if we factor that trinomial. So from there, we get 8 or minus 7. If we're talking about factorials, you can never, ever, ever take a factorial of a negative number. So that one doesn't work. So the answer is n equals 8. Okay? So we use our factoring skills in order to help us there, and it definitely goes ahead and makes a big difference. All right, so practice some questions on this and make sure to reach out if you need help. I'm here for you if you need help. You just have to let me know how I can help you. Okay.